Alright, so welcome back to this lecture series on signal and systems. So in this part of this video, we are going to be looking at the causal, non-causal, and anticausal signals. So we are going to be looking at what each of them is all about. Alright, so like I said in the previous video, if this is the first one that you're coming across and you've missed the previous part, kindly check the playlist on signals and system. You'll find a link there. And if you are yet to subscribe or you are new to this channel, please take out time to click on that subscribe button somewhere here on your screen. At the lower right of your screen, you see a red box with subscribe on it, so kindly click on it to subscribe. Alright, so I'm just trying being playful here. Alright, so thank you, and then let's get started. Alright, so for the first one I want to look at is the causal signal. Okay. So what do we mean when they say a signal is causal? So by definition, so causal signal is one, or let me say this is a signal that has zero value. For the negative time. Alright, so that's the definition. If you have to define what causal signal is, it says this is a signal that has zero value for negative time. So now let's do a drawing of it so that you can understand it better. So if I have this now, and now let's look at this together. So don't forget that this is going to be our x of t, exactly, and then this is going to be our t. So just like the definition, it says it has zero value for the negative. Okay, this is a signal that has zero value for the negative time. Yes, I missed one for the negative time. So that's it. So if you look closely, you see that this horizontal line is for the time, exactly. And if that horizontal line is for the time, this is the positive side of it, and then this is the negative side. So let me just write negative t here. I'm still saying the same thing. All right. So what it says that this is a signal that has zero values for the negative time. What's saying to say that on the negative side there are actually no values. So if you have to draw a diagram to represent causal system, and once you draw your 4 cardinal points, you indicate your x of t, and then you indicate your t, the positive and negative side of it. So you can just have something like this. So let's take this to be our signal, exactly. So you can see that this signal is actually on the right side, on the positive side of the diagram, exactly, of the graph. So you can see that for this particular signal, it has zero value for the negative time. That means on this side, you can see that there is no value. It has zero value, exactly. So that's just basically what causal is, exactly. So just for proper understanding, that's what causal signal is. So now let's quickly look at what non-causal signal is. So for non-causal, so that should be the number 2. So non-causal signal. So we can define that as saying a signal. The signal is said to be non-causal if it has zero values, or sorry, if it has non-zero values. Non-zero values for both the negative and positive time. Alright, so what does this actually mean? You can pause the video and try to understand what they're saying. He said a signal is said to be non-causal if it has non-zero values. So let's look if it has non-zero values. This is just the keyword there. for both the negative and positive time. These are the two things that can help you to determine what the diagram will look like. Exactly. So now let's put this also. Let's see what the drawing will look like based on what that definition is saying. Okay, so this is our, let's call this plus t, yes, and this is the minus t, and then right here is our x of t. All right, so the signal is said to be non-causal if it has non-zero values. So what's that trying to say? Try to understand what this part is saying, non-zero values for both the positive and negative time. So that means whatever this non-zero value actually means, it will be for the positive and negative side. That means it will be on this side and on this side also. But now let's see, what's the meaning of non-zero values? That means on the positive and negative side, there are going to be values. When they say non-zero values, that means there's going to be a value that is non-zero. Remember that 0 is just at this point here, where the horizontal and vertical meet. So that's where the 0 is. So when it is now non-zeros, that means there are values here. And that signal has negative values, it also has positive values. That's another way. So when they say it has non-zero values, that means on the positive side, which is here, there's a value. On the negative side, which is here, there's also a value. Exactly. So let's just do a rough sketch of what the signal might look like. So if you have a signal, that means it's going to extend either from positive to negative or negative to positive, but it's going to occupy from the negative to positive, or not positive to negative. Exactly. All right, so this is just what the diagram for non-causal will look like. So if you should compare it now with causal, you can see that for causal it has 0 value for the negative time. Now you can also say that it has non-zero value for the positive time. I hope you get what I'm saying. So you can also define causal like that it has non-zero value for the positive time, or you can say it has 0 value for the negative time. So it's just for understanding. I hope you get the concept. So it's not something that you actually need to memorize. Just understand it. All right. So now let's look at the third one now. So we've looked at causal, we've looked at non-causal, and then now let's look at the third one is anticausal. So for the anticausal, so if you are to define that, you say that it has 0 values. It has 0 values for the positive time. It has 0 values for the positive time. So this is just like the name anticausal is the opposite of what we have for causal signal. So for this now, if you are to draw it, if you are to have a diagram to express what anticausal looks like, so positive, negative t, so this is going to be our x of t, right? So since it has 0 values for the positive time, so that means nothing is going to be on the positive side. We are just going to be having, depending on what the signal is, on the negative side. So you can just use this as a representation of what anticausal signal is. So that is it on causal, non-causal, and anticausal. I hope you find value in this. If you do, please give it a thumbs up. And if you are still yet subscribed, please just click on that subscribe button somewhere here. Or just anywhere under the video, you'll see the subscribe icon there. So that is it. And then in the next part of this video, we're going to be looking at energy. We're going to be looking at the determinant. I've just tabbed on. All right, we're going to be looking at deterministic and random signals. So I'll see you all in the next in that video. Thank you.